Members of the Allied Control Commission for Germany arrive at Marshal Zhukov's headquarters in Berlin to sign the joint agreement. General Eisenhower is on hand to represent the United States. Marshal Zhukov makes it official for Russia, and Monty adds his signature for Britain. The next to ratify the agreement is France's General de Tassigny, who is followed by our own Ike. Official British pictures of the men who will control the post-war destiny of Germany. Hitler's mountain retreat at Berchtesgaden has been transformed into a GI playground. Hitler is gone, but his butler is still on hand, Arthur Kallenberg, who, with his wife, took care of all de Fuhrer's personal needs. None seems very grieved at their loss, if any, and that goes for both the butler's niece and his wife. Yes, the GIs have taken over, and the men of the 101st Airborne even have Hitler's lofty eagle's nest at their disposal. He is said to have used it only 4 times.
I'm going to talk about some hidden technology that was taken from World War II on a cleanup mission through Nazi Germany just shortly after the war, which is the Lockridge Device, of which I have right here. I'm going to tell you a little short story that just shortly after the war, 2 soldiers were assigned to do cleanup operations through probably something that was going on under paperclip or something. And
Project Paperclip.
yeah. Well, I don't know much about paperclip, but
that was the program where we repatriated Nazi scientists to
right.
the U.S.
Yes.
And it was known as Project Paperclip.
Anyway, one of the soldiers' names was Lockridge, the last name. And I guess they stumbled across in a warehouse this machine that was running, known as the Lockridge Device, which was self-powering itself. And at that time, of course, it was built from a Bosch generator. So I guess what the soldiers did was they never turned it in to their commanding officer. They just packed it up in a box and got it at home and worked on it when they got home. And the little thing about Lockridge was that after the war, he was known as the town drunk. And anyway, a little explanation of the machine. What this machine was a converted Bosch generator that had sort of like a pull cord. And you flipped a switch, and you wound the cord around it, and you gave her a pull. And she took off and went ding, 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 until she got up to 5,000 RPMs, at which point in time you could draw a maximum load of 300 watts. And of course, at that time, it was light bulbs, because they were using it for lighting and a small little wire-wound 6-volt heater. But if you exceeded the 300 watts, you killed the machine. So, a little explanation of the machine is the generator casing, everybody knows, is this iron casing. And what was done different is a normal generator would have its poles, say, like this. And then the armature would be in between her. So you'd have a north pole here and a south pole here. And then you'd have some brushes here. And then, of course, you normally in a generator, one would go to one brush and the other one would go to the field wire. and then the armature, which is in here in commutator segments. And you always, with a generator, when you replace a generator, use a generator, is you always polarize the generator so that there's some residual magnetism in these poles. So if you just took the normal generator and put a pulley on it and then wrapped a pull cord around it and gave it a pull, it would self-energize itself and light the headlight just for a few seconds and then go back out. But that's not the Lockridge device, because what the GI has actually seen was something far different. They couldn't figure out where the power source was or where the battery was that was running this, so they just stopped the machine forcefully, from what I understand.
What do you mean forcefully?
Forcefully, put their foot on the rotating mass.
Okay.
And stopped it. Of course, the lights went out, and they packed it up and hid it very well. Got it back home. Got it back here to the USA. And this is, I think that this is somewhere down in Boise. That's where the people that own these Lockridge machines were to be found at the time. Of course, they're all dead now, and most of the houses have been torn down. And anyway, the Lockridge device was very unique in that it had one pole piece here, one pole piece here, one pole piece here, and one pole piece here, which made it a 4-pole motor. But 2 of these pole pieces were generators, and the other 2 were motors. So this is a motor, and this is the gen. Now, something very interesting here, because this was a North Pole, and this was a North Pole, and this was a South Pole, and this was a South Pole. Well, you see, it's not 6 poles, it's 4 poles. So, in between these portions of the poles, very conveniently, if this case went backwards like this, a slot was cut to divide the case in 4 places. And we'll get a close-up on this in a minute, because there's a reconstruction of it here that they tried to rebuild that didn't work. But remember, from all my past videotapes and everything on scalars and magnets, that I said if you put 2 north poles together, push them together like this, you get a beam that appears here. So the magnetic field sort of looks like this. It's very sharp. And this is actually very detailed. But that's basically what the beam looks like. And it's north here and north here. And it's a pinpoint beam, because normally the North Pole, the magnetic field goes like this. So I've always said that by doing this, by pushing the 2 north poles together, that you're creating a scalar beam, pinpoint scalar beam. So what was really going on in this thing was the generator and the motor. The generator's a constant thing, and the motor's a switch thing. So between these two, you have an attraction field when it's generating, because these are energized. And then when the motor turns on, what happens is these 2, it interferes with this field and wants to push like this. And so it's going to do the same thing from this side. So what you have there, and then by splitting the case, you have two norths, north here and a north here. So they want to take that, they want to take this scaler away, so they slot the case so they don't interfere with each other. But anyway, that's just a little explanation on the scientific end of the Lockridge device, and basically what was going on in the functioning of it and what's going on with these in this case, electromagnetic beams, not permanent magnet beams. But, so anyway, the problem with the Lockridge device was that, number one, even though it was an overunity machine, and it only produced 300 watts of usable power while it self-ran. So if you maintain the 300 watt level, the machine continued to run until the brushes wore out. Now, something very unique, if we look at the brushes that make up this, you can get a close-up here. Notice the size of the brush that's here. It's very thin, you see it?
Okay, that's the brush at the very end. Can you put your finger on it again?
Yeah, I'll point to it here. See, it's very thin.
Right.
And it's in a special made holder.
Right.
So that you can adjust the... But here's the next thing. This brush, when we look at it, fits only one segment of the commutator. See, it doesn't even hit the slots.
Okay.
And the reason for that is that between two of these segments in the commutator is just a motor action. Now, the thing about this is that it needed, what they found when they took it apart, and these are reconstructions of what they found, that this casing right here had a special wound coil. These were all twisted together in here. And that went on this case. And of course all these wires are because they tried to reconstruct it, but you can see that the case is slotted between these two poles. See here? So it's a split case. And the reason for that is so that the magnetic fields don't interfere on this side, here and here.
So that's the split case. And
That's the
where
split.
don't they want the...
Okay, so they don't want these two magnetic fields, these two norths, to interfere out here.
Right.
See? And here, between the souths. All right?
Right.
So this acts on the motor side as a big inductor, because this was in series with the motor pulse. And it almost acts like the monopole motor, into where the coil becomes and gives you that sharp spike. Well, the next unique thing that's missing from all this is that, and I'm going to erase this, is that they built their own capacitor. And what Lockridge did, since he didn't have any money, is he would take the copper off transformers, and there'd only be about this much, and then he'd solder this together so that for about 35 feet. And he'd do this twice. They'd get enough copper to get 35 feet, and this was about just a little bit wider than what you see this coil here. So the copper was wound from, it looks like about from where this terminal is to the end case here. And what they would do is they'd put two together, butcher paper in between.
But by butcher paper, you mean
Waxed butcher paper.
Did
that
they
you
wrap-
get in- Yeah,
they wrap the meat in it?
yeah. And then they would wind this around the case as a capacitor. Now that's a pretty big capacitor, but it charges very fast because it's not a lot. It's just real high voltage. It's like 400 volts. So when you take that 300 or 400 volts and these two brushes hit in exactly two of these commutator segments, the motor spins because of the residual magnetism that's in these coils. So it's actually a series wound motor. And what I mean by series is a coil, commutator, and a coil. Like that. So our commutator is in between here like this. And this one goes to a brush the way he had it hooked up. And this one went to a brush the way he hooked up. And you can see the brushes here. I'm actually moving that one there. See? Very special arrangement of brushes.
So these are the original brushes?
These are the original. This is exactly built that people that own the machine told the guy that built it.
So this is a replication.
This is a replication of what they tried to build back from that day.
From the original machine?
From the original machine. And the original machine was a Bosch generator, which was a 6-volt machine, and then, of course, they needed a 12-volt generator, so they tried all kinds of 12-volt generators. They tried Ford and they tried Chrysler, but the only one that would work was this Delco Ramey. Its case and the way it's arranged. It's the only one that would work. And so we've got our condenser, and so what we're doing is we're catching, when we gave this thing a pull, the generator, the motor switching actually, there's 3 windings here, see? So it's trifilar. Okay? So one of these was on the generator side and one of these was on the motor side, and the other one is part of the circuit that helped charge this capacitor. And so this capacitor built a great big charge of about between 3 and 400 volts. Because a few claimed that when they didn't build the capacitor right, when Lockridge didn't do the capacitor right, it would short between here and there, and he'd have to replace the butcher paper. He'd have to wax it more.
It's blocking the...
So we know all this. The thing is that there was no solid state circuitry during, just shortly after World War II. We had vacuum tubes, but we really didn't have any transistor circuits. So the mistake that was made here is not that the coils were wound wrong, or the case was done wrong, or the armature's wrong. It's this. they tried to make it solid-state switcher. Well, they did successfully get the motor to switch, but this is not the correct way to do it when it was a total mechanical device and using the 4 brushes to do the switching. So here's an example of everything that they did, and quite a few drawings from people that they talked to about how this machine was put together and where the pole pieces were. And a lot of notes from talking to people.
You say talking to people, talking to what?
Talking to people that actually own the machine.
Okay. Whose notes are these? Who took the notes?
I really don't want to say his
Okay.
name. But
But
anyway.
this is somebody who had access to the
Yes,
original.
yes, this is somebody that had access to the original people that worked for Lockridge. And what Lockridge did is he hired basically people that were, I would say, a little slow in learning. Slower than most. In other words, because he was only going to give them one job, and that job was to just make this coil. And they knew nothing else. Never did one of them actually see Lockridge assemble the machine. So not one of them knew exactly how this machine went together. It's just notes and pictures of them trying to construct the machine. And you see he made notes of what he was doing. And tests. So the man that tried to